exterior angle of a regular polygon. So keyword there is regular polygon. So if it's regular, that tells you what about the angle measurements? They're all the same. All the interior angle measurements are the same. What's it tell you about all the exterior angle measurements? They're all the same as well. Okay, so that you need to know. You need to gain that from that vocabulary word. Okay, it says find the measure of an interior angle, then find the number of sides. Okay, so if we have an exterior angle, okay, it says the measure of an exterior angle of a regular polygon is given below. Okay, so I don't know what my number of sides are. I don't know what this thing looks like, but I do know it's a polygon, and probably a little portion of it might look something like that. Would you guys agree with that? Okay, so I'm going to just kind of draw a rough sketch just to get some organization, some filling in some information allows me to make a conclusion here. They say the exterior angles are 60. So that angle there would be 60, right? Good. That would be 60. That would be 60. Now, however many more I have, they're all the other ones are going to be 60, right? What does every exterior angle, what is the relationship between every exterior angle and its adjacent interior angle? Tyler? Supplementary. So this green angle here has to be what? 120. Okay. So that would be, I think, probably the best approach there to find the measure of one interior angle. Okay. There are other ways of doing that, and I'll show you the other way after we get the next part of this question done. The next part says find the number of sides. Be able to basically name this figure. Okay. Here's the idea. I can't do that without one of these two numbers. And it doesn't matter which one I use, but I have to use one of these numbers. This is the way I would do it. This is the easiest way to do it. If these are all 60 on the outside, right? Okay? And I've got a lot more of those angles. I don't know how many more I have, but I've got more of those 60-degree angles existing. What should they all add up to? 360. Okay? So I've got 60 plus 60 plus 60 plus 60. I don't know how many times, but eventually they're going to add up to 360, right? Well, if I take a number and add it to itself over and over and over again, 60 plus 60 plus 60 plus 60, what operation is a little bit easier to use instead of addition? Multiplication. So I have 60 times some amount. That amount I'm going to call n should equal 360, right? I should be able, that 60 times n is showing that I'm adding up all of my exterior angles, and they should total 360 degrees. So now how do I solve for n in this case? Divide by 60, and n becomes 6. So this thing is a hexagon. Call it a hexagon, because that's what, and of course, again, it's going to say, you're not wrong by saying sexagon, but depending on who's reading, I don't know how they're grading the, of course, exams right now with regards to some questions can be graded using, even if you type answers in, they have algorithms that can read your English and make sure that you've written the right answer. But they can also have humans reading them. And I don't know if a human sees sexagon, whether they're going to accept it or not. I don't know if that's going to be in the rubric. Hexagon will probably be in the rubric. Okay. Is that doable? All right, another way of doing that, another way of finding that idea that it's a hexagon is to use this formula that says n minus 2 times 180 degrees divided by n gives me one interior angle. Okay, and that's for a regular polygon. Do we know one interior angle right now?
Yeah.
Yeah, we know it's this 120, right? Okay, so I can take n minus 2 times 180 over n is equal to 120. Multiply both sides by my denominator, so they cancel out there. So I get n minus 2 times 180 is equal to 120n. So then I get 180n minus 360 equals 120n. And now I get negative 360 equals negative 60n, right? Well, is that the same thing as saying 360 equals 6n? Is that the equation that we came up earlier in the other method? Okay. So it's an alternative method that gets me down to the exact same equation. And we just have a better way of getting to that equation using the exterior angles. But if I divide both sides by 6, I'm still going to, or sorry, it should be a 60. Divide both sides by 60, I still get n to be 6, right? Okay. Either way is fine. I'm thinking that, that's a lot of extra algebra in regards to using that formula, n minus 2 times 180 over n. Okay? But it is 100% feasible. Nothing wrong with doing it that way. Any others on there you guys want to talk about? Do we want to do another one of those, or we feel comfortable seeing just one of them? Comfortable seeing one? Okay, so we've got, let me zoom in on this. It says find x, and then any unknown angles in the quadrilateral. Zoom in on this thing. All right, so in this one, this is extremely similar, if not the same as what we did with triangles early on in the year. If I had all these unknown angles in a triangle, whether they gave me them numerically or they gave me them with algebraic expressions, I would take the three angles, add them together, and set them equal to what? 180. Okay. Now I've got four angles. Some of them I know numerically, some of them I know algebraically. Okay. I'm going to add those together again, but now what would my total be that I set it equal to? 360. Okay. So every time you see one of these problems, the first thing you need to do is figure out what the total is for your polygon. Okay. So all four of these angles, when I add all four of those angles together, it should equal n minus 2 times 180. N being the number of sides, so 4 minus 2 is 2 times 180 is 360. So I have to do that every single time I see one of these problems. You're going to see this in your homework tonight. That I give you a handful of these where it goes from quadrilateral, then it goes to a pentagon, and then it goes to a decagon, and then it goes to a hexagon. And each one is going to be a different total that you set everything equal to. Okay? So now we're going to add these together. We're going to say 4x. My tab for a second. 4x minus 90 plus 90 plus 85 plus x should total then 360, right? Yeah. Okay, what's nice about that is the minus 90 and the positive 90 cancel each other out, right? Yeah. I have 5x then is equal to remove 85 from both sides. Okay, so that's going to give me what, 275? Yeah. Okay. Divide both sides by 5. X is going to be 56. Is that right?
I don't know. Is it right?
Goes in there, no, 55. 55. X is 55.
You're pretty good at math in your head.
Huh?
You're pretty good at math in your head.
I use it a lot. Okay, so X is 55. So what do you have to do then? It says find all missing angle measurements then, right? Plug it back in. So coming over here, we got 55 there. 4 times 55 would be what, 120?
Yeah.
120 minus 90 is 30, right?
30.
I'm sorry, it's not 120, it's 220, isn't it? 55, 220 minus 90 is 130, right? 130. We should be able to go through and add those four angles up, 130, 85, 55, and 90.
And get 360.
And get 360. That's the built-in check to make sure you've done this correctly. Okay. If you go on to the next question, just wanted to take a quick look at that. 26. Maybe.
I don't know why it never hit me, but it never hit me that he was 90 degrees.
Okay, so this one here, what is our total again?
360.
360. The only thing different about this question is that,
More x's.
yeah, more x's. Every angle is now an algebraic expression, but you simply just add them all together, set them equal to 360, solve for x, and then you go back and plug in and find angle P, angle T, angle S, and angle R individually. Okay. So my hope is that you guys realize we have already done a lot of this, right?
Yeah.
We've done a lot of this with triangles. Now it's just doing the same thing with quadrilaterals, doing the same thing with pentagons, doing the same thing with hexagons, except for the right-hand side, instead of being 180, the 180 is going to now fluctuate. It goes to 360, maybe 540, whatever. Okay.